Good afternoon. My name is Benyamin. I'm in charge of the LA Water and Power System. So I'm going to give you a little bit different perspective than Don because of the way we're structured and the way we operate the utility. So in contrast with Edison, the Department of Water and Power is a balancing authority that controls the generation, the transmission, and the distribution of power supply. So if there was any case study that could be done with all the policies coming together from the generation all the way to the customer, including the feed-in tariff and the once-through cooling policies and renewables and reliability and everything, the department sees it all from A to Z. Compared to Edison, the regulated portion of their business is basically looking at the distribution only, and they're kind of disaggregated from the generation, and the control area is with the Cal ISO, which controls majority of the state. We are independent from that system. So a lot of things that I'm going to tell you about is more from the perspective of the reliability and running a system from an operator perspective as a utility controlling all the aspects of the energy segment. So this is just starting from a high level. The city of Los Angeles, with 4 million customers that we have to serve, the city of LA has generating resources that reach all the way to Bonneville Power Authority, to Delta, Utah, to the Intermountain Power Project, to Navajo Generating Station in the border of Utah and Arizona, the nuclear power plant, which Edison and us are bringing power in from Palo Verde. That's part of our mix, and also Hoover, which we are with Edison also bringing power from there, and also a lot of renewable resources along the water system that we have coming from the Owens Valley, that we combine water and power activities as we bring water down to the city of Los Angeles. So we have about close to 1.5 million meters that we have to serve in the city of LA. And as you can see, the reach of the sources that we have kind of goes across 4 different states and a lot of different mixes of energy that we have to integrate. And I'll touch a little bit about the integration issue as we get closer to that. But as you can see, that over the 100 years that we had, the utility was basically pretty much the same model. We generate, we transmit long distances, and we bring the power in, we integrate it. It was much more stable from an electric model perspective than what we're going to see going forward, and I'll touch on that a little bit. This is the end of the DC line. Let me see here if I can use the right here. This point is this power plant that sits at the end of a DC transmission line, about 530 miles. Back when I had lots of hair, I was up there about 30 years ago at this power plant. But it is a large coal-fired units, 900 megawatts each, sitting in the middle of nowhere, basically in the state of Utah, and that is going to change as we move forward. This is a picture of our DC line, the Bonneville Power, coming from Bonneville Power, the Pacific Intertie. Edison has half the capacity on this line. We share the operation of this line coming into the Southern California area, and we integrate it at the Sylmar point. Just to give you the percentages, as Don mentioned on the Edison side, we are heavy in coal at this time. And this is a 2010 snapshot, but we have about 40% of our energy comes from coal-fired units. And those are basically on the existing contracts that we have to figure out a way to get off of coal and go into something that's more compliant with the rule that we have, the SB 1368 rule. And as we go forward with the renewables from where we are at the 20% to 33%, and change the coal to other resources, sometimes it feels like you're on a plane that's flying at 40,000 miles, and you're trying to tinker with the wings and change the engines and do a lot of these modifications as the system is running. So and the portfolio that we have in 2027, and the reason why 2027 is there is because the power plant that you just saw, basically the city of LA will be the end of the contract with that coal-fired plant. So as far as the date, 2027 is the last day, I mean, last year in our forecast that we have, that we will have coal in there. And then you see in the pie chart that there is no coal in our portfolio by 2027 at the latest. This is our renewable portfolio standard as we stand today. We took a snapshot at 2010, we reached 20%. We have several mixed resources, wind being the most dominant, solar being picked up, and as we go forward, those pie chart slices are going to change because of that physics of integrating these resources into the system has to meet the criteria of the reliability and making sure the system is balanced. So depending on how the system grows, that technical portion, the question that we have to reliably integrate these things are going to come into play. This is a wind farm about 70 miles from LA, northwest of LA, that we own, we operate, and we maintain. It's about 135 megawatts of wind power. But alongside of that, and talking about the policies of land use and maximizing the use of resources that we have, you could see this portion of the land that we don't have for wind development. We're planning on, actually we're mobilized right now when we're grading the area for putting in solar generation underneath the towers there, so we can kind of maximize the use of the land that's not being used for wind. The ownership and the philosophy of owning, the city of LA has owned the assets from day one, and for 100 years we've always owned and controlled our generation and our destiny as far as bringing energy, and that philosophy is not going to change as we move forward with the acquisition of these resources moving forward. So all the RFPs and acquisition requests that we have in there has a component of owning those resources, because as technology evolves, we want to be the one that's going to repower these renewable power plants, and we want to be able to evolve as the technology evolves going forward. This is a good stacking order of what we have as we go from 20% to 33%. The green side just kind of highlight the importance level of the energy efficiency that we have. We want to invest as much as we can with energy efficiency and technologies to make sure we control the growth moving forward, so we make sure that whatever resources we add, we are spending a lot of effort on the energy efficiency side. Solar, as Don mentioned also, solar is being a dominant renewable resources that we have. We are forecasting a larger segment of the renewable growth in the solar area. We have the wind as much as we can integrate. We have some geothermal coming online, and we also have the biogas and other resources that will take us to 33%. But from a utility perspective, this 33% really, it's just a random number as far as the physics of integrating this. It could be that at the end of our integration process, it could be 36.7 or 38 when we are all done with integrating the right amount of resources, because we can't control the segments of where projects are economically feasible to do. So we don't want to say we're just going to reach 33 and stay there. So when we're all done, that percentage could be much different than 33, but by law, we have to be at 33%. Some of the topics that we've discussed before, the power purchases are the dominant mechanisms for us to acquire these resources, for tax relief and other financing mechanisms. But eventually, we're going to have the feed-in tariff grow, and then we have the solar incentive programs. And then this portion of the growth that we have is a combination of private and public partnerships where we have design, procure, permit, and then we have our own crews actually do the integration, because the way we want to integrate these solar resources are along the way of our transmission line, and they tie in right into our substations. And we want to have that partnership between private and public to make these things work. This is an actual picture as of Friday at the Adelanto switching station that we have close to close to Barstow. This is a 10 megawatt solar that we're putting right next to our station, and you can see the racks up there. But this is a land that we own and resources that's pretty abundant over in that area. And it's a pretty, technically it's pretty interesting to have a 10 megawatt solar tie into a DC terminal, which is the end of the Utah to LA line. It's the direct current line that ties into the station, and we're tying into that system. This is more of some pictures of installation of our crews. You know, any public facilities or anywhere we could put in solar. We have a whole backlog of facilities that we want to make sure that's part of our kind of a fill-in projects that we have. We've seen the convention center. We've done a lot of public libraries and other public facilities, put solar in there. And one of the issues that we brought up is this integration issue. And when you look at the generation resources that we have, about 3,000 megawatts of our generation is 40 years plus, you know, old technology, supercritical units that takes us about 3 years to dispatch. That model is going to go out the door. No more, you know, having these large blocks of power plants sitting there where we order them online and it takes 3-4 days for it to ramp up. With the integration issues and the variability of these resources coming in, we are looking at 5-minute to 10-minute order and coming online type of technology. Those are the things that we want to invest, and part of the once-through cooling retrofits that we're doing, we're integrating the operational needs of the system with getting off of ocean cooling. And we have a schedule that kind of outlines these units that we want to take in sequence and get off of ocean cooling and then put new technology to make to do exactly what I just described as far as making them much more responsive to the system so we can balance these renewables coming in. This is an aerial photo about a week or so ago at the Haynes power plant. This is 2 units that we've taken offline that are one of those old 45-year-old units, and we're putting 6 100 megawatt fast start units across you know, this piece of land that we have next door, and that's going to be 600 megawatts of highly effective, integratable, all kinds of technologies that we will put in place, including the voltage support and everything else that we need to have to balance our system. And this is about a $750 million project, just these 2 units. As far as the philosophy of getting off of coal, and I brought up the issue of integrating these policies and the requirements. So you have, up in the air, you have all these policies that are coming together, but you cannot look at these individually. You cannot just look at, I'm just going to get to 33% and then forget about the technology to integrate them. I cannot get off of coal and then say I'm going to have it all renewables, or gas a little bit and renewables, and these have to be integrated in a very, very organized way so make sure that the reliability is kept whole. And basically the philosophy that we have on getting off of coal, this is one of the first units that we're going to get off of by 2015. This is the Navajo power plant, is for us not to jump from coal to gas, because this is an easy solution right now, is to say, I'm going to lose 477 megawatts of coal. I'm just going to jump in and do a combined cycle equivalent to the capacity that I have, and I'm done. Because you have 5 other things in between your coal replacement and your acquisition of a resource to replace it. So the order, the stacking order that we want to go forward with, which is a risk abatement and also reliability issue and economics, is if energy efficiency, do as much as you can with energy efficiency, control your demand side, load up your systems with all the renewables that you can, because you have to get to 33% anyway by 2020. And then make sure this is a balancing equation to make sure that this whole system acts just like the 477 megawatt of coal. So this is a concept that's part of our IRP going forward, and that's the way we're executing all the plans going forward. And that's the end of my presentation.
We can take
Questions?
a couple of questions specific to this this presentation, then we'll have some, but I'd like to leave some time for some general questions at the end.
Briefly, at the beginning of your presentation, you mentioned there are changes coming to the IPP project. Are there changes coming before 2027 that may have effects on the other joint agencies that are taking into power from IPP, or is that when you say changes to coal coming after 27?
The units, we can, IPP is almost half of our generation today. For example, half of the units, the energy coming into LA is coming from IPP. So the transition period exactly, come 2027, that's the cliff. We're off. So somewhere between 2022 and 2027, there's going to be a transitional period. IPP initially was made for 4 units, and we have only 2 units in there. So we basically have 2 additional pads that are all built, ready to go. So any transition that we do from coal to gas / solar / anything else can be done parallel to having the units running and then do the cutover. So exactly how that's going to happen, it's not going to happen 2027. It's going to happen somewhere between 2022 and 2027. How and what the scope, it's still up in the air.
So you don't anticipate it having any effect prior to 2020?
It's hard to say, but we have plans in place right now to kind of react to any sort of variation that we can't afford to have that thing at risk at all.
Let's
Go
take
ahead.
one more question, and then otherwise we'll keep the rest for the general question period.
You mentioned in your slide that the combination of different renewable energy plus conservation that you're going to get to the goal. How do you quantify this conservation? How could you manage this conservation through your customers? Is there any way that you can manage it that at a certain amount of energy you can save? Or
Several ways. I mean, it starts, nobody wakes up in the morning and say, today I'm going to go and save energy. I mean, it's just not part of our habits. I mean, if some of you who have kids in the house, I mean, it's an education to just make the awareness of that, you're wasting energy, in ways that it doesn't take much to change your habits to conserve without really impacting your way of life. But in addition to that, I mean, technology-wise, we have several programs on demand response, where we have these industries that are fit for controlling the demand side, like refrigeration, large refrigeration industry, or industries that don't affect their businesses, is for us to partner with them and make sure that we can either control their demand at the peaks, and make sure we partner with them, and also energy efficiency, things like lighting control, when nobody's at these places, that the lights are not on, unnecessarily. So schools, parkways, anything that we could do to incentivize and implement efficiency, it's the cheapest source of energy that we could have in our portfolio. So it's an economic, and also it's conservation, and also it's a good thing to do.